Hello everyone. In this video we're going to be solving a geometry puzzle which is a very special one because this is a Sangaku. According to Wikipedia, Sangaku are Japanese geometrical problems or theorems on wooden tablets. So I will share with you more information in the description down below about where this problem was adapted from, and then you'll be able to see the details. All right, let's go ahead and get started. So we have two congruent circles and a unit square. So the diagonals, one of the diagonals of the square is drawn, and then as you see here, two congruent circles are inscribed and we're supposed to find the radius. Okay, so what makes one of these lines so special is that the circles are congruent. Okay, awesome, great, let's proceed. So what I'm gonna do is, this problem is a little different from the other ones. First of all, it's a very ancient problem. I just slightly modified it. And it is a really cool problem too. So I think in many senses, this is different from the other puzzles. So I think this is a special one. Anyways, let's proceed. So since the radius is r, we can just go ahead and, call that r. So let's go ahead and make a connection here. This is going to be r as well as this one. Okay, awesome. Now, what do we know? We're gonna name some lengths here. So let's see. Since this is a unit square, obviously it measures 1 by 1. So this is 1, this is 1, and this is 1. Okay, what else do we know? We don't know this length here, so let's call that x. Okay, since I don't know that length, let's call it x. Therefore, this is going to be 1 minus x. Awesome. And we also don't know the hypotenuse here. Let's call this hypotenuse a. Awesome. Okay, and then what about the diagonal? Well, this is a 1 by 1 square, therefore the diagonal from Pythagorean theorem. So at least we've used the Pythagorean theorem once, right? So again, this problem is different from the other ones because we're not going to heavily use the Pythagorean theorem in this one. We're going to do it a little differently. Okay, so the diagonal here is going to be square root of 2. Awesome. So what are we going to do here? Well, we're going to use some area formulas. First of all, let's start with the right triangle here. In this right triangle, whose base is x and whose height is 1, we can just go ahead and write down a couple things, right? Like what? Okay, I can safely say that since it's a right triangle, I can find the area, right? So what is the area going to be? Base times height divided by 2. So the area of this right triangle is going to be x over 2. Fair enough, right? It's fairly simple. Okay, what about writing the area in a different way? So my goal is to find r. So do you know of any formulas that involve r? There's a formula which I could call, I guess, SIR formula. A equals SR. I hope everybody's familiar with that. Here, S is the semi-perimeter, right? And R is the in radius, which means the radius of the in circle, which is the one that's inscribed. Awesome. So by using that formula along with this one, I can actually come up with a nice equation here. What is that going to look like? Well, according to that, I have to find the semi-perimeter, which is x plus a plus 1 divided by 2, right? X plus a plus 1 divided by 2. And then I got to multiply that by the radius, which is r. Beautiful. Now, what makes this even more beautiful is that the 2 cancels out. Then we actually get a nice expression for r. So from here, r is equal to x over x plus a plus 1. Beautiful. That is one expression with 2 unknowns. So we don't need another equation. And where is that going to come from? It's going to come from the other triangle. Okay, and that triangle has a base of 1 minus x. But what about the height? The height is the same. These two triangles have the same height, which is 1. So the area would be easy in that case as well. So the area would be base times height, which is 1, divided by 2. So the area of the second triangle, whose base is 1 minus x, is going to be 1 minus x divided by 2. Awesome. Let me emphasize this base one more time. Cool. What am I going to do next? Okay, so we need to set it equal to the SIR part of the equation. The semi-perimeter for the second triangle, which is not a right triangle, it's an obtuse one, right? Is going to be what? 1 minus x. We have the 1 minus x. We have the a, and then we have the square root of 2. Awesome. And of course, this is going to be divided by 2 for the semi-perimeter and multiplied by r, same way. 2 cancels out, so we have a similar story. And from here, r is going to equal what? R is going to equal 1 minus x divided by 1 minus x plus a plus root 2. Awesome. So we do have now two expressions for r, and we can set them equal to each other. Is that the end of the story? No. So stay tuned until you hear the end of the story, because that's going to be a really cool end. Awesome. So, but I will get started with this. First of all, I want to get something that I can work off of. So I'm going to set these equal to each other. So that's going to look like x divided by x plus a plus 1 equals 1 minus x divided by 1. Okay, one of the things I can do is possibly, I don't know if that's going to help a great deal, but at least I'm going to put these numbers together for some reason, you know, and then plus a minus x. I'm going to write the x last. Okay, cool. So next step would be here to cross multiply, obviously, right? So let's go ahead and cross multiply here and here. So that's going to look like what? Well, first of all, I can keep the 1 plus root 2 together. I think that helped a little bit. Then I'm going to multiply this by a. So it's going to be ax and then minus x squared. So that is equal to this. So you can do this in different ways. I'll probably start with 1 and distribute the 1 over. That's going to give me the same thing, x plus a plus 1. And then minus x distribute over that expression. That's going to be minus x squared minus ax minus x. Awesome. Now, this expression can definitely be simplified. Let's go ahead and simplify this a little bit. How do we simplify that? Let's see. Negative x squared cancels out, obviously, right? And I do have x minus x here, which is 0. Beautiful. Okay, what else can I do? And also, you got to remember here, like, what am I trying to solve for, right? Okay, so, yes, okay, I'm trying to solve for x and a at the same time, kind of, right? But which one would be better for us to isolate? So we got to think about it at least, right? So let's go back here and see if we can find another relationship. Awesome. If you look at the right triangle right here, don't you see that x squared plus 1 squared is equal to a squared? Awesome. Well, I said that I wasn't going to use the Pythagorean theorem much, but that's it. This is for the last time I'm using it, right? Hopefully. So this tells us what? Well, it doesn't necessarily tell us, but I think finding the x would be nice because x is cool. Okay, is that good enough? So what am I going to do then? Well, since this equation kind of has a by itself, why don't we go ahead and get the a by itself in my other equation as well. So to keep a long story short, I'm going to isolate a. Therefore, I need all terms that have a in them on the same side. So let me go ahead and keep this guy here and bring this one over here. So it's going to be 2ax. Okay. What else do I have? I have an a here. So let me go ahead and subtract the a. So that's taken care of. Now, I do have a 1 here, right? And I don't want this on that side because I want to isolate the a. So I'm going to subtract it, but it's easy with the parentheses. So let's keep that number inside parentheses like this. And everything is taken care of, right? 1 is taken care of, all the variables and numbers and so on and so forth. Okay, great. So this is going to give us something nice because we can factor out a now. And it's going to give us 2x minus 1. I know this kind of looks complicated, but don't worry, it's going to simplify. And you're going to get a really nice result from here. You'll be surprised. Okay, a is equal to what? 1 minus 1 plus root 2 multiplied by x divided by 2x minus 1. Beautiful. So I was able to get a by itself, which is cool because I also have another equation for a. A is equal to the square root of x squared plus 1. But I don't need to go into that. I can just square both sides, right? So a squared is equal to x squared plus 1. So let's go ahead and put these two equations together. Let's square the first one. If you square the first one, a squared is going to equal this guy here. It's kind of gigantic expression, right? This will be squared, right? And that is going to equal x squared plus 1. Beautiful. Now I was able to get rid of the a. Now the only variable is x, and we're going to solve for x. Even though this equation looks complicated and it's going to turn into a quartic, we're going to be able to solve it, which is what makes it so much fun. Okay, how do we solve it? Well, I'm probably going to not factor, but square the top, all right, like this. And I'll take care of it in the next step. And then I'll square the bottom, but I'm just going to go ahead and cross multiply. I hope you don't mind me doing 2 steps at once, but I think this should be fairly straightforward. Here we go. Okay, now we can go ahead and expand this as much as we can. The left-hand side, 1 minus 2 times 1 plus root 2 x plus 1 plus root 2 squared times x squared. So if you square 1 plus root 2, that's going to be 3 plus 2 root 2. Again, I'm skipping a step here. I hope you don't mind. Equal to, okay. This one is going to look like, let's not skip this step, and I'm going to expand this one, 4x squared minus 4x plus 1. Awesome. Now, if you go ahead and distribute here, and let's see, what can we do? Well, I got to keep the left-hand side as is, so why don't I just start here? Go ahead and distribute that because it has bigger terms. 4x to the fourth minus 4x cubed plus x squared. So I'm distributing the x squared first, and then I'm going to distribute the 1, which means that I'm just going to copy the same thing. 4x squared minus 4x plus 1, and this is the right-hand side, so that equals the left-hand side, which is equal to this one. I'm going to arrange these terms a little bit here to make it more organized. You know, it just looks better that way. Plus 1. Awesome. I think this is what we have, right? Okay. Again, this looks complicated, doesn't it? It's like a quartic, and to make matters worse, we have some radicals, but don't worry about any of these things. We'll clear this out. How? Well, we have 4x to the fourth. Awesome. No x cubed on the right-hand side, so this is good. Now, I have x squared plus 4x squared, which is going to make 5x squared. So I'm going to get 5x squared, and this will be subtracted. So what do you get if you subtract 5 minus 3 minus 2 root 2? That's going to give you what? 2 minus 2 root 2, right? So that's going to be my coefficient for the x squared on the left-hand side. Okay, so I'm going to have 2 minus 2 root 2 multiplied by x squared. So all of this is taken care of. Now we end up with, and these are taken care of, obviously. So we know what is left. That's why I underline these things. Okay, so we're going to bring these guys over here with a positive term. So that's going to be like 2 plus 2 root 2. And then I have the minus 4. So that's going to be what? That's going to be a 2 root 2 minus 2, because 2 minus 4 is negative 2, multiplied by x. So this is taken care of, and this is taken care of. Awesome. I only have 1 left, but guess what? We have 1 on both sides. Isn't that beautiful? It's just beautiful. Why? Because they cancel out, leaving us with a nicer equation. Even though it's quartic, we can turn this into a cubic. Why? Because x is a factor. Awesome. Let's go ahead and do that. So let's take out x. And obviously, we know that x is not going to be 0, because in that case, we don't have the other circle, right? Okay, so we have to have 2 congruent circles. So this is going to be for x cubed, make no mistake, plus 2 minus 2 root 2 multiplied by x plus 2 root 2 minus 2. Multiply by nothing. I mean 1. Okay, cool. Nice. Look at that. Not only this becomes a cubic, but also it becomes a nice cubic. And why is it so nice? You'll see in a little bit. So stay tuned, okay? Let's see. From here, I get x equals 0, blah, blah, blah. But again, this is not valid. X cannot be 0. So we're going to deal with the cubic. How do we deal with the cubic? Okay, first of all, I want you to notice the following. You know, we always do this check. We must replace x with 1. What is the sum of the coefficients? When you replace x with 1, you're going to notice that 4 minus 4 plus 2 minus 2 root 2 plus 2 root 2 minus 2. This is 0. This is 0. This is 0. Wow. The sum of the coefficients is 0. What is that supposed to mean? Well, it means that x equals 1 is a solution. What is that supposed to mean? It means that x minus 1 is a factor. Okay, cool. So what is that supposed to mean? It means we can factor it out. Beautiful. Okay, let's proceed. How do we proceed? With a nicer color. Let's use this one. Okay, cool. Now what I'm going to do here is I'm going to factor out 4x squared, and this color is really nice, don't you think? X minus 1. And what about these guys here? Okay, cool, no problem. We're going to take out here this 2 minus 2 root 2, okay? And then, let me show you, okay, fine, I'll take another step. Minus 1 times 2 minus 2 root 2, okay? Cool, is that better? Equals 0. Now look at this. We have a common term, and then we get x minus 1 from there. Awesome. Everything is awesome. Okay, great. So now we get 2 minus 2 root 2 multiplied by x minus 1. I told you it's going to have a really, really nice ending, right? We're nearing the end. Okay, let's see what happens here. Okay, x minus 1 out. Cool. And now what do we have in the other one? 4x squared plus 2 minus 2 root 2 is equal to 0. Beautiful. Awesome. Now, obviously from here we get a solution x equals 1 when we set it equal to 0. But guess what? If x equals 1, then we don't have the other circle. So the circles are disappearing, right? At x equals 0 and x equals 1. Those are kind of like the extreme values. We don't want those. We want something in between that's going to give us two nice circles. Just like this one. Look at the picture, right? Isn't that beautiful? Two nice circles. Okay, so we need x to be between 0 and 1, not 0 or 1. Okay, we don't want that. So we're going to discard that value as well. So we end up with, okay, we end up with what? We end up with this value. Now, this is a quadratic, right? Yes, but it doesn't have an x term, so it's super easy to solve. How? Set it equal to 0 and see what happens. Let's continue with another color. Let's pick this one. Okay, cool. So now set this equal to 0 and enjoy the rest. What am I supposed to do? Isolate the 4x squared. Now this is a positive term, so it has a real solution. Nice. Let's divide both sides by 4. Okay. And you might be tempted to simplify this, right? What? Did I write 4? No, didn't. Nobody saw that, right? Okay, so divided by 4. Now, you might be tempted to simplify this, but don't, because we're going to take the square root, right? And obviously, there are two square roots, but I don't think you want the negative one. Do you want the negative solution? Oh, x cannot be negative. It means then that's going to be a point outside the square. We don't want that. So we're going to deal with the positive solution, which is going to be what? Just square root this. So it's going to be this one. You see, that's why I did not simplify this in the first place, because I wanted to keep the x nice. But guess what? We're not looking for x. We're looking for a. Wow, that's kind of crazy. But guess what? We have a nice expression. You don't have to use the radical one. Like, remember, we ended up with two values for a, right? This is a squared and this is a squared. You don't have to use this one. You can use this one. It's a lot easier, right? So we know that a squared is equal to x squared plus 1, right? A squared is equal to what? We reached the end of the document and it's a white page. Wow, that's kind of interesting. Okay, looks like I only made 6 pages and this is the 5th page. And for some reason, the last page is not the same color as the other ones, but that's perfectly fine. So this is my conversion formula, and I do need, what am I trying to find? Well, I'm trying to find the R here. No, not the A. Okay, what is R then? Okay, so I gotta get to R somehow, right? What is R? Okay, here we go. This is R. Beautiful. Okay, well, guess what? In order to be able to find R, I'm gonna need the A value and the X value. So that means I'm going to be using both of them. Okay, no problem. We can handle that. We can definitely handle that. So let's go ahead and take this expression and plug it in. So I'm going to be getting a plus 1 plus root 2 minus x, 1 minus x divided by that. That's going to be my R. Okay. Okay, awesome. Let's go ahead and substitute that. Okay. So I have R is equal to 1 minus x divided by 1 plus root 2 plus a minus x. Let me check that. 1 plus root 2, 1 plus root 2 plus a minus x. Okay, awesome. 1 plus root 2 plus a minus x. So this is my R value. I have my x value and I have my a value there. So let's go ahead and do the following. Let's find the a value. So a is equal to square root of x squared plus 1. So what I'm going to do here is, actually I already have the x squared, so I might as well just add 1 to this, right? And then just square root it. Or doesn't matter, no big deal. Well, at least I have the x squared value. So this is going to look like 2 root 2 minus 2 over 4 plus 1, and then I have to square root it to find a. So from here, a is going to look like what? Okay, it is going to look like 2 root 2 minus 2 plus 4 plus 2. Okay, so to keep a long story short again, I'm going to give you the answer, and a is going to be this one. Okay, Awesome. So A kind of looks like X, doesn't it? Okay, it does. Okay, they're kind of like conjugates. Nice. So that's the A value, and then I gotta find the R value. Let's go ahead and find that. R is gonna equal, and at this point we might wanna change colors, maybe use a darker one. How about this one? Okay, so R is equal to what? R is equal to 1 minus X. So let's go ahead and substitute that everything together. 1 minus X, which is that guy over here, 2 root 2 minus 2 over 2, and then divided by, so I have 1 minus X again. So this guy is going to appear twice. So let me go ahead and write it down this way. So once I find it, you know, I can just go ahead and simplify or just use it again. So 1 minus square root of 2 root 2 minus 2 over 2. So that's 1 minus X, this one and this one. And then I have the plus root 2, and then I have the plus A, right? Plus A, which is this one, by the way. It's going to be this one. So square root of 2 root 2 plus 2 over 2. Since these two guys have a common denominator, I can actually go ahead and just add them up and include the other guys as well and end up with a nice value for R. Okay? All right. So it looks like we're given an extra page here. I don't know why. But anyways, let's just proceed. So what I can do is actually I can go ahead and multiply everything by 2, both the bottom and the top, so we can get rid of the fraction, and let's see what happens. So when I multiply by 2, I should be getting 2 minus this guy here. All right, for the R numerator. A denominator is going to be 2 minus this guy, because that has a 2 at the bottom, plus 2 root 2 plus the square root of 2 root 2 plus 2. All right, awesome, great. Now, can this expression be simplified? Yeah, it can be, but it's going to be a little bit of time consuming, and it can definitely be done. But that's the radius of the circles. All right, well, that's it for today. I hope you enjoyed the video. Please comment, like, and if you haven't subscribed yet, please do subscribe and hit the notification button. And I will see you tomorrow with another video. Take care, be safe. Bye-bye.